This is problem 39 of chapter 16 from the textbook Stats Modeling the World, second edition. So what we have here is we have a farmer that's been harvesting apples and potatoes, and he's going to take 100 pounds of apples and 50 pounds of potatoes to the market and sell them. Now apparently the price for apples as well as the price for potatoes varies. It's a random variable, so it varies. So in other words, what we have here, think of it as we got this farmer that's got his old flatbed truck here. Doesn't look that much like a truck. Maybe if I put some wheels on it, it looked like a truck. Okay, so here he is in here. Modern day truck. He's a farmer, so he needs to have a hat on. Okay, and so he's got some bins or something of apples. So he's got 100 pounds of apples. And then also on his truck, he's got 50 pounds of potatoes. So the price varies. So the expected amount for apples. So it says here, it says define your variable. So let's just do that. Let A be the price per pound for apples, and let P be the price per pound for potatoes. Okay, so now we could say the expected value for apples is going to be $0.50, I guess. And the standard deviation for that price is 0.2, so 20 cents. And the expected value for potatoes is going to be 30 cents, looks like, with a standard deviation of 0.1, so 10 cents. So it varies a little bit, not a lot. Okay, so find the mean. So that would be the expected value. So mu, the mean, is the expected value, and he's taking both to market. So do they tell us anything else? It also cost him $2. Okay, so I think what we have here is it's gonna be 100 pounds of apples. So whatever price he's going to get, he's going to multiply it times 100, and then it's going to be 50 pounds times the price per pound for potatoes, and then he's going to subtract off $2 because that's how much it cost, I guess, for gas or something. So let's see. One thing to realize here when we do this is he's only going to market once. Okay, he's only going to market once, and then we're scaling, we're multiplying. It's not like he's taking 1 pound of apples to market, getting a price, then taking another pound like that. So the random variable is only happening once. Okay, so what this would be then is the expected value of 100 apples plus the expected value of 50 times the price per potato, and then we're going to subtract off 2. So this is just equal to 100 times the expected value of apples plus 50 times the expected value for potatoes minus 2. So now we can plug this in. So the expected value is up here, 0.5 and 0.3. So 0.5 plus 50 times 0.3 minus 2. Okay, and that's going to be, I did it here somewhere. I guess I'll just have to do it. So 100, can almost almost guess or figure it out. 0.5 plus 50 times 0.3 minus 2. Let's try that one more time. Clear. 100 times 0.5 plus 50 times 0.3 equals minus 2 equals, so it's 63. So it sounds like $63. Okay. So let's see. Now we want to find the standard deviation. So the standard deviation, first we would need to calculate the variance. So we use the same notation, 100A plus 50P minus 2. Okay, now that's going to be equal to the variance of 100 times the price expected value, or the price of apples, plus the variance of 50p. And we don't, this goes away. We have a formula for this. The variance of x plus c is just equal to the variance of x. In other words, even though we're shifting things by this operation, it doesn't change the variability. Okay, so now the important thing here is to see that this event is only happening once. So we have another formula. We're going to square this, and that's the variance of A plus 50 times the variance of P. So there's another formula that says that the variance of AX is equal to A squared times the variance of X. Okay, so now we would plug in the standard deviation of A squared. So the standard deviation of A was 0.202 plus 50 times 0.1 squared. Let's see if I can do that on the calculator. So 100 squared times I did that wrong, didn't I? This should be 0.2 right there. So let me try again. 100 squared we know. 100 squared times 0.2 squared equals plus 50 squared, I gotta trust this calculator, times 0.1 squared equals 245, or 425. So 425, exactly. So now that makes it nice. The standard deviation of 100A plus 50P minus 2 is going to be the square root of 425, and so that's easy to do. That's going to be 20.62. So 20.62. Yeah, that's good. Sorry, I wanted to check. Okay, so that's how you do these computations. So it says, do you need to make any assumptions in calculating the mean? So no assumptions are necessary to compute the expected value. However, to compute the standard deviation, we need to assume the price, the sales price for apples is independent of the sales price for potatoes. Okay, and vice versa, I guess. Okay, so that's how you answer that part of the question. Okay, good luck.